Okay, me again. When I say wrap, I'm going to show you a number of interglacials and the common features they share. What we have here is an interesting graph. It's done by a meteorologist in America, James Covington, and he decided what he would do is he would take each one of the short interglacial spiky bits and plot them on top of each other and leave out the long bit in the middle that's where it's very cold. And that's what these four graphs here are. The red one is us now. We are on the red line here. You can see I've actually annotated this. You know, the red arrows and the most of the commentary is mine. But here are the four time scales at the bottom. Each one of these scales are thousands of years before present. So they apply they're color coded with the graph that's plotted above them. On the actual graph, what have we got? We've got one division per degree and 1,000 years per division going along the x-axis. So this is all nice and straightforward and easy to see. So pretty much what you can see what the form of an interglacial is. It comes up from maybe 14, 12, 14 degrees, maybe more than that, up to 18 degrees colder than now to a peak over about 7,000 years. It's quite, if you see, it's quite reliable. It's 11,000 to 18,000, 7,000 years. And that's the green, purple, and blue cyan lines. Our interglacial didn't quite make that cut. For some reason, something went horribly wrong in this Younger Dryas period. Geology doesn't have an explanation. But the interesting thing is it knew where it was going because it ended up back on track about 9,000 years ago and has been generally following what the other two of the other periods now did. And it's nice and flat along for 9,000 years ago to 3,000 years ago. Yep. And then it starts off heading down towards the next glacial phase, 75,000 years of that. But you can see that now is not at all unusual. It's colder than it was 3,000, 4,000 years ago. And as I said earlier, it's rather obvious here if you look at any of these traces that you're seeing a cyclic variation on about 1,000-year period. There's other variations going on within that, but it's going up and down about, these are polar plots from ice cores in Greenland and in Antarctica, because there are no ice cores from Greenland more than two interglacials, more than one interglacial back. So again, if you look here, you'll see up and down about 2 degrees every 1,000 years, and you see that in the green line, the purple line, even this weirdo here. Something happened weird in this particular cyany coloured one, but again, look at it. Ooh, and something went wrong there as well. But in general terms, you, first of all, we wouldn't expect things to be exactly the same every time. Second of all, it's fairly obvious that you are getting variability in the range of 2 degrees per 1,000 years throughout these cycles, and that now is colder than the normal interglacial stable level, the optimum level, and that all happens at 280 parts per million of CO2. And it doesn't look as though the 420 parts per million we've got at the moment, we are here on the red line, has any effect. I mean, it does, it's small, but it's not the dominant control of climate. I hope that's clear. So that's it. I hope I've made my point. You really, really have been totally misled. It's very, very obvious that you've been lied to, and the people are lying to you are so sure that you won't check these facts that they're happy to carry on doing it. And the whole basis of, in the United Kingdom, the Energy and Climate Change Act, which is destroying your energy infrastructure, doubling your energy prices and making your industry uncompetitive, is this single statement that CO2 causes disastrous climate change, and it dominates disastrous climate change, sorry, when it clearly does not. Thanks for your time.